Hello everybody, welcome to another screencast for Research Skills 1. Today I will show you how to make tables in SPSS. There are two basic type of tables that I want you to be able to make. That's the frequency table for a single variable and the frequency table for two variables. The second one is also called a crosstab. We'll start with the frequency table. You can find it under Analyze, and then Descriptive Statistics, and then Frequencies. You can have frequency tables for different variables. Let's take the bottom three of these to see what happens. We'll put them all over here. I will uncheck all of these because I am not interested in these. And then I'll press OK. So right now I'm getting a lot of frequency tables. I'm getting a frequency table on the question, what did you think about Nick Fury on a scale from 1 to 10? I'm getting a frequency table on gender, so what is your gender, male or female? And I'm getting a frequency table on education. What is your educational level? High school, bachelor, or master. In some cases it doesn't really make sense to get a frequency table. For instance, if you have a variable that has quite a high measurement level, has the possibility of having many different values, in this case value 1 through 10, then you can get quite long frequency tables. They're not informative anymore. In this case, this is borderline. I don't think it's informative anymore to look at the frequencies. How often do you get a 10? How often do you get a 5? This is not informative anymore. You can imagine this only gets worse when, for instance, you're measuring age. And age can run between 16 and 30, or between 16 and 80. You can get lots and lots and lots of values here with all very uninformative percentages next to them. That's why it's my recommendation to only stick to using frequency tables for variables that have measurement level nominal or ordinal, like gender, nominal, and education, which is ordinal. So in this case, you can see that exactly half the people in this group, 50%, 40 out of 80, were female, and the other half were male. So that's what a frequency table does. It gives you the frequency of a particular instance, a particular answer occurring. Here we see the same data, same type of data for education. We can see that out of the 80 people, 17 only went to high school, 43 have a bachelor degree or are currently pursuing a bachelor degree, and 20 have a master or are currently pursuing a master degree. If you look at that in percentages, from this 80, that 100%, a quarter, 25% doing masters or have one, 53.8, more than half bachelor, and a fifth, or near 20%, 21.3% are in high school or have a high school diploma. So here are the absolute numbers. Here are the relative numbers, percentages. These are useful because you can compare this particular group of people with another group. So let's say you set out your questionnaire a second time. You can look at the results of that questionnaire and compare it here. Do I have the same distribution over groups, more or less? That's why percentages are handy. If you do that with absolute numbers, the comparison is not good, because let's say you have 100 people in that questionnaire, then 20 out of 80 is 25%, a quarter, but 20 out of 100 is much less, but the absolute number is the same. This will not be reflected in the percentage, so that's why a relative number like percentages make more sense to report. Well, there are two more percentages that are reported. One is valid percentages, valid percent, and the other is cumulative percent. Valid percent has to deal with the fact that sometimes there are people that don't actually fill in your questionnaire, or not all parts of it. They skip parts. They are filtered out by filter questions. Maybe they didn't go on a holiday, so they can't say anything about holidays. Or maybe they didn't see a particular movie, so they can't say anything about a movie. What valid percent does is calculate percentages not relative to everybody who filled in the questionnaire, but relative to everybody who filled in the particular question you are analyzing. In this case, everybody filled it in, so these numbers are the same. But imagine that for this particular question, there were 5 people that didn't really want to fill in what their educational level was. Valid percent would then calculate the percentages of these numbers not out of 80, but out of 75. So they would be slightly different here. What cumulative percent does is already in the word cumulative. It adds everything up until you reach 100%. So everybody in high school, that's 21.3%. Everybody in high school and a bachelor, those two groups together, is 75%. All 3 groups together is 100%. So that is the simple frequency table. You do this to analyze the frequency of particular answers occurring for a single variable. In other words, it's a univariate analysis. Now let's look at the bivariate analysis, where you compare 2 different variables. This can be done with crosstabs. You find them in the same menu, so that's Analyze, then Descriptive Statistics, and then crosstabs. For instance, let's compare education with gender. Well, there's a couple of things you need to activate here. You can go to Cells. You'll see several options that don't make any sense to you. What will make sense to you are the percentages, the row and column percentages. You select those and you press Continue. And then OK. So here we have a cross-tabulation, a cross-tab, a frequency table for 2 variables. We are comparing gender with education. So we're looking at all the females and see how they are distributed across these educational levels, and we're doing the same for males. Again, we have the absolute numbers, which SPSS calls count. So 9 and 8, 20 and 23, 11 and 9. We can calculate percentages in 2 ways. We can see within females, so there are a total of 40 females, what percentage has a particular level of school. So out of these 40 females, 20 have a bachelor. That means that of the 40 people, 40 females, half, exactly half, so 50% has a bachelor degree. So that's within gender, calculating percentages. So within this column, also known as column percentages. We also have row percentages. So then we're not looking at female and male, within female or within male anymore. We're comparing them within high school. So if we're looking at everybody who's in high school, 17 people, how many of those are female and how many of those are male? Then we look at these numbers. So nearly half, 9 out of 17, and also nearly half, 8 out of 17, have a particular gender. So 52.9% is female, 47.1% is male. So those are the row and column percentages and what they mean. So always take good care which percentage you order and how you interpret it. My recommendation in this case would be always, when you're interested in one particular aspect, one particular variable driving an effect, like for instance you want to know the difference caused by gender, so you want to know the difference between male and female, always put those in the columns and then just order the column percentages. So it's easier to interpret what you're doing. So that would work like this. You go to crosstabs, you make sure that the thing you're interested in, the thing you think may cause a difference, is in the column, and you just select column percentages. So those are the percentages you are actually interested in. So For instance, you want to know which group has more people in the master group, then you can see that females, women, relatively speaking, have more people in the master group than men. There you go. I'm not giving a value judgment on this, it's just data that you can interpret. So these were the two types of tables that I want you to be able to create. One is the frequency table, which is an analysis of a single variable and seeing how often a particular answer comes up. And the other is a cross table, a cross tabulation, a bivariate analysis where you can compare two different variables with each other. Make sure, though, that these are always nominal and ordinal. Again, if you have lots and lots and lots of different answer options, which you can get with interval or ratio measurement level variables, a cross tabulation wouldn't make sense anymore. In that case, always do compare means and then means. The effect of gender, for instance, on the opinion on Iron Man, Tony Stark. Compare these two means. Because a cross tabulation for that same opinion would give a very large table, which is hard to interpret. It's not really informative anymore. Okay, good luck running these analyses, or at least creating these tables for your own data sets.